Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams PFM, IFM, and LTAM that I offer. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help ISU actuary. Here's a problem for today for exam P on probability. A company buys a policy to ensure its revenue in the event of major snowstorms that shut down business. The policy pays nothing for the first such snowstorm of the year and $10,000 for each one thereafter until the end of the year. The number of major snowstorms per year that shut down business is assumed to have a Poisson distribution with mean 1.5. What is the expected amount paid to the company under this policy during a one-year period? And here's the solution. So let us write N for the number of major snowstorms per year, and let P be the amount paid to the company under the policy. N has a Poisson distribution with parameter 1.5 or 3/2, so probability that n is equal to n is 3/2 to the nth times e to the minus 3/2 over n factorial. The lambda parameter of this Poisson distribution is 3/2. And this is for n equal to 0, 1, 2, and so on. All non-negative integers are the possible values. And the amount paid is 0 for n equal to 0, because if there are no snowstorms, then there's no payment. And then it's no payment if there's one snowstorm, but after that it's 10,000 per snowstorm. So if there's a positive number of snowstorms, and denoted by n, then the payment is 10,000 times n minus 1, because of not paying for the first one. So for n equal to 1, 2, 3, and so on, the payment is 10,000 times n minus 1. Well, then it follows that the expected value of P is the sum from n equal 1 to plus infinity, because for n equal to 0 there's no payment, 0. So it's n equal 1 to plus infinity of that 10,000 times n minus 1 times the probability function of the Poisson distribution that we have, which is 1.5 to the nth, e to the minus 1.5 over n factorial. And, well, the unfortunate thing is that we start this series from 1 and run to plus infinity, and the Poisson distribution starts with 0. Well, we'll just add the term for n equal to 0 and subtract it. So we add it in the series and subtract it out front there. And subtraction would produce minus 0 minus 1, because when n is equal to 0, 0 minus 1, times 10,000 times 1.5 to the 0 times e to the minus 1.5 over 0 factorial. Okay, minus negative 1 is 1, so this whole expression in front is 10,000 e to the minus 1.5, and the second expression is just the expected value under this Poisson distribution of 10,000 times n minus 1. So we have 10,000 e to the minus 1.5 plus expected value of 10,000 n minus the expected value of 10,000. Expected value of n is 1.5, the parameter lambda of the Poisson distribution. So the expected value of 10,000 n is 10,000 times 1.5. So what we have here is 10,000 times e to the minus 1.5 plus 10,000 times 1.5 minus 10,000. And we just calculate this, and this is approximately 7,231, which is answer C. Please remember this is copyrighted material. The problem itself comes from Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.